Assalamu alaikum, dear students. I hope everybody is doing well and you are in good health. So this is the presentation for lesson 2. In this lesson we will be discussing more on the enzyme production using biotechnology. Actually I discussed already last lesson about this, how the enzymes are produced in a fermenter and what are the different requirements for a fermenter. Describe. So in this lesson we will cover this part, how to immobilize enzymes to save costs, and state what are some commercial uses of enzymes. Okay, so let's say now you have produced your enzymes and you need to immobilize it. So the cost associated with the use of the enzymes for industrial purposes can be actually reduced by immobilizing the enzymes. What does it mean, immobilizing enzymes? So this is what we are going to see. So immobilizing the enzyme is actually by binding them or by trapping them in a solid support. Let's say I have produced my enzyme for a certain purpose. Let's say this is my enzyme, the round circle here is my enzyme. So I need to use it, but I want to reuse it, so I don't have to buy every time the enzyme. Alright, so this one will save me cost. So if I find a way to reuse my enzyme, I will make more profit. So there are different ways to immobilize your enzyme. You can use, actually, since we know that the enzymes there are proteins are slightly negatively charged, I can use actually a polymer, and that polymer is actually positively charged. So I will create here like kind of hydrogen bonds or ionic bonds between my enzyme and my support. So my enzyme will be trapped. Alright, so my enzyme will be binding to this support and I can reuse it many times. So the enzymes here are held on a solid support like matrix by weak forces such as hydrogen bonding. This is one way. Another way is actually by using like kind of net. Like you use net to catch your fish. So this is a kind of net used from some beads or chemicals or polymer to trap your enzymes. So you will keep using your enzymes. So enzymes are trapped within the structure of a solid polymer, usually is in the form of beads. The enzyme is trapped rather than bound. So here it's actually trapped, but here it is bound by these ionic bonds. Okay, once I do that, what I can do, I can pack my enzyme inside what we call columns. So this is our columns. So enzymes are matrix, and matrix are packed into columns. So this is my column. So now whatever liquid I have, I want to do some digestion in that my liquid, I will just use this my enzyme over here. I pour my liquid, then the enzyme will do the job, and after that I can reuse my enzyme. Okay, so I give you an example here using lactase. Okay, some people actually they have what we call lactose intolerance. They cannot digest lactose when they drink milk, because as you know, milk contains lactose, the sugar. That's why when you drink milk you feel some sweetness that comes from lactose. So the people who don't have this enzyme in their intestines, what will happen to them? They will have some bloating, and they will have also some stomach ache. So for these people, it's better for them to drink what we call lactose-free milk, means a milk without lactose. So how can we help these people? So we just produce the lactase. We already know the gene which produces lactase, so we will produce it. Or we get any fungi or any bacteria which can produce this lactase, and we produce the lactase using the fermenter. Now we have our lactase. we have the choice. First scenario, we can actually add our enzyme to milk. Our enzyme will digest all the lactose inside the milk, then it will be lactose-free milk. So it will be safe to use by those people who have lactose intolerance. But in this case, your enzyme will be mixed with the sorry, your enzyme will be mixed with the milk, means you cannot reuse it. So the enzyme is mixed with milk, it can't be reused. Means every time you need to prepare this lactose-free milk, imagine you have a factory and you need to prepare this lactose-free milk, means every time you need to buy enzyme lactase, means you are going to spend a lot of money buying this enzyme. What if another smarter scenario where you can save money? So you need to immobilize your enzyme by using this bonds or by using the net. So what you need to do here, you just pour your milk in the column, then the enzyme will break down the lactose, and tada, you have your milk here without lactose, and you and some more is pure milk. You don't have any other products here, like in here you have enzyme. So your enzyme you can reuse. So the enzyme can be reused again. So which scenario is cost saving? Of course, the second one. Okay, so if you have a factory, you always have to think how to increase your profit by saving money, by saving cost. Okay, so the advantages of immobilizing enzymes. So the beads, so this is, you have the matrix, your column. So the beads or matrices are packed into columns and the substrate is poured over them at optimum rate. So you are going to add your milk or other chemical or other products. Then immobilized enzymes can be recovered and reused, reducing overall cost. So this is what is good in this technique. Then here the products of the reaction are not contaminated with the enzyme. Here your product is not contaminated with the enzyme, eliminating the need to undertake costly separation of the enzyme from the product. So you don't need to do any more other chemical reactions to remove your enzyme from the product, because your enzymes is safe here in the column and you can even reuse it. Okay, so immobilizing enzymes allow for continuous production rather than batch at a time. Okay, so some commercial uses of enzymes are listed below. So proteases, why we need to produce these proteases? They are used in washing powders for dissolving stain from egg, from milk, from blood, to remove the hair from animal hides. This one usually for those people producing leather for to make shoes or bags. We need also the proteases in cheese manufacturing and tenderizer meat. So this one, I don't know whether your mothers are using this one, because we can you can buy it in a shopping mall. You can find it with spices. So this one usually are enzymes. You mix it with the you put it on your meat, leave it for about half an hour, then you cook your meat. It will be very tender and it will not take too much time to cook. Okay, so you have lipase. Why we produce these lipases? So they actually flavor enhancer in cheese. They enhance the flavor in cheese, and we can use them also in washing powders to remove fatty acids or fatty stains. Sorry. You have also pectinase. Okay, here if you want to make to have a factory for producing juice, you better buy this pectinase. Yeah, why? Because this pectinase actually will maximize the juice extraction. It will give you more juice, and it will clarify the fruit juice. It make it more transparent. Okay, and here you have the last example for amylase. is actually production of glucose from starch, because a lot of people need to be injected with glucose, especially those diabetic, when their blood sugar goes very low. Okay, so the example of washing powders, you have here the proteins, proteases and fat digesting enzymes lipase are used in washing powders. So they are effective in removing stain in clothes because or caused by proteins, example from blood or egg or gravy, and fat like grease, etc. Proteins and fat molecules tend to be large and insoluble. So proteins and fat are insoluble. So they will be broken down by the enzymes, means proteases and lipases. So like uh, like proteins, they will be broken down into amino acids, which are small and soluble, and fat, they will be broken down into glycerol and fatty acid, and those also are small molecules and can be easily washed out. So biological washing powders save energy because they can be used to wash clothes at lower temperature. You don't have to boil water or to heat the water in your washing machine. So proteins here, stain, like from blood, from sweat, are removed by proteases, which break down into amino acid, and the fats like oil or grease are broken down by lipase into fatty acid and glycerol, and these are two soluble molecules and small, so can be washed away. Okay, so we said that they are cost effective using the washing biological bio washing powder, so or bio detergent. So here their effectiveness at low temperature, because you don't have to heat water, because the proteins or the enzymes can be active at normal temperature. So temperature means that they work at lower temperature, means that they are less demanding of energy and produce less wear of the clothes. Okay, you have an example here of a bio detergent, and I just want to show you this one. So here they are using bacillus protease. Okay, you don't have to memorize this one, don't worry, it's just show you this uh, composition of this bio detergent. Okay, so here we will see a very simple experiment using pectinase and how it will affect the juice production from an apple. Let's say you take two apples, A and B, and you put the pulp, exactly same amount of pulp, apple pulp in both tubes, and you are going to add pectinase in beaker A and no pectinase in here. So, and we will see what will happen. So first you are going to crush the pulp, you are going to crush it, and you are going to incubate the two beakers in a water bath at 40 degrees Celsius, and let the enzyme in the beaker A break down the tissues of the apple. Okay, now after incubation time, you are going to use a filter to filter the juice from the apple pieces using coffee filter paper in a funnel placed in the measuring cylinder. So this one, you just simply filter it. Then what is the result? The result is actually from the same amount of pulp, you get more juice from in beaker A than beaker B. Beaker B, you got very little juice and it will be cloudy. But in beaker A, you will have more juice and will be transparent. Why? Because actually the pectinase you added here breaks down the apple tissues, releasing sugars in solution. So more juice is produced when pectinase is added. So if you are planning to have a factory for juice, you better use pectinase. And another very simple experiment here using biological powder. Let's see, here we have egg yolk and another egg yolk here. In this one we put biological washing powder, and here we put ordinary washing powder, and we incubate. Okay, let's say 1 hour, 2 hours. So what will happen? Okay, with biological powder, there will be no egg yolk at all, but in the ordinary one, the egg yolk is still there. So what happened here is, because you have enzyme, that enzyme will digest the egg yolk. Egg yolk is made of fat and protein. So the protease will digest the proteins into amino acid. So you cannot see them, the amino acid, they are soluble. And the lipase will digest all the fat into fatty acid and glycerol, and of course they are also small, you cannot see them. But in ordinary washing powder, the egg yolk is still there because it doesn't have any enzyme. So the enzymes in the biological washing powder break down the proteins and fats in the egg into amino acid and fatty acid and glycerol. They are smaller soluble molecules and dissolve in the water. So this is the case here. But in this case, there will, in the biological, ordinary washing powder, it's less effective because it does not contain any enzyme. Okay, so I will stop here. Thank you for watching. Thank you for watching and listening.